Hello everybody, this is Calculus Challenge Question Drill number 4, a multivariable integration. Now, we have a situation here that it is asking a volume of this function within the boundary, which is 1, 1. This area, right? Because x equals 0, y equals 0, and x plus y equals 1. So basically the triangle area, and this exponent function is like, if you look at the x, it's going like that. Right? It's a height, and x, and the y the same way. So you have a height increasing toward this way and increasing toward this way, and also this way. Okay, so how do we calculate this? Now I want have you ever wondered if you could do this, like the integral is the opposite of derivative, right? And if you have a boundary AB, you just get f b minus fa. So just find this fx integral function, right? Integral function, and you can get this. The df dx is fx, correct? So why can we do this? Okay, now derivative and integral is not exact opposite. It's two different math concept. It just share some concept, which is infinitesimal small numbers, infinite. That kind of concept is utilized in both derivatives and integral. That's all. It's not really often you see this apply only for some primary function. In this case, if you dare to say fxy is 2x plus 3y, because this shows a height, right? Multivariable derivative is dx plus y dy. Okay, so this part I will say three y dx, and this part dy, right? So that's gonna be the derivative of df. Okay, this is fine, but when you ask a volume, the volume has a boundary, and when you apply the boundary, this doesn't get you anything, because if this is not height, some kind of density, molecule density, density increase this way, right? Okay, so what's the rate of increase, which is this guy on the x and increase of density is this guy, the y, and dx dy corresponding give you total increase df, which is a total density increase. Well, instead of height, it can be density, anything, right? So you can get function of the density on x and y. Okay, what if we say, okay, calculate all the molecules within this region? Again, there is a boundary, so this doesn't help, right? So it's a how you deal with the boundary is the independent math tool you have to learn besides delivery and integral, this opposite relationship. Okay, so in this case what we do is we take at x dx this strip and we calculate this. In order to calculate, you need y, right? So y equals 1 minus x. So the boundary is going to be the function. So obviously the first boundary for 2x plus 3y dy is going to be the variable boundary. Okay, so if you take 2x here and dx 0 to 1, this gonna be right? Sorry, you cannot separate this because you have this 2x here and dx together 0 1. Okay, yx is 0 to 1 because this strip, you add up all the strip between this range, and depend on x, strip height is different, and that's reflected by this guy. Okay, so this is the boundary manipulation, right? So you clean up minus 3 dx 0 1. Okay, then it's a simple integral. So this boundary, how you handle this boundary is nothing to do with derivative. This is integral, unique math concept. So you have to practice this, how you set the boundary, because when you ask some integrated value in multi-dimension, you specify the boundary, and the boundary is x, y, z all related. It's going to be function. So function goes into the boundary, and you keep integral one by one. First, you calculate this strip at point x, then integrate x from 0 to 1. Okay, so that's a way it's handled. Okay, if you like this video, please subscribe, and if you subscribe, you get another new calculus drills, and if you like it, please click like. Thank you.